Hi, welcome to section 1-2 notes for points, lines, and planes for honors geometry. I know we went over some of these notes in class on Thursday or Friday, but we got to different spots in the various classes, and I know some people were absent that day, so I'm going to go ahead and start at the beginning, but you can go ahead and go to the spot where we left off in your class and just continue from there. So in terms of points, lines, and planes, we first talked about looking around the room and trying to find an example of a point, line, and plane. So there are many options, but for a point, one thing someone mentioned was the corner of the room. Even though we don't actually see a dot in the corner of the room, it still represents a point in space. So I'm going to go ahead and fill in. Actually, I am going to move this up a tad bit. And I'm trying to get used to writing on my screen here. So let me move this up a tad bit. Let's see. So that we can see everything down below. There we go. That's where I want it. Okay. So like I said, the example that someone gave for a point was the corner of the room. I'm going to have to get used to writing on this. Some people said the tip of my pen or a dot on the wall, various things you could think of there. If we look down below that, it says the description of a point. And again, these words, point, line, and plane, are undefined terms, meaning, when geometry was created, they developed these words, they gave a description of these words, and then everything of geometry is kind of built upon this. So a point indicates a location, a spot in space, but it technically has no size or shape. Even though it might look like it in the book or on a piece of paper, it technically has no size or shape. The way that we can model a point in the book, you will normally see it as like a dot with a capital letter beside it. So say point A. But just to be clear, say you see a picture of a rectangle and say there's an A beside that corner of the rectangle. Even though there may not be a dot at the corner of the rectangle, you would still consider that a point. That is where two lines are intersecting, so that would be considered a point. It is named by a capital letter. Okay. And then the last thing we have here is the word or symbol. And if you were trying to name a point, you can just use a capital letter. That is completely fine. If you're going to name multiple points, you can just put capital letters with commas in between. If you want to write out the word point and then the A, that's fine, but that is not necessary. You do not have to do that. Okay, so now if we go through line, if you look around the room you're in right now to look for an example of a line, again, there's lots and lots of lines in your room as well. I can say in my classroom, the edge of the board. I think it's one thing someone said. The flagpole. Someone else said the lines on the ceiling. Someone said where two walls meet up, that's like a line. So again, lots of lines that you can find around the room. The edge of your desk. The description of a line is it's represented by a straight path that extends in two opposite directions without end. So again, that line is going to go forever and ever in both directions. It technically has no thickness or width, just like we said, a point has no size or shape. Same idea there. And it contains infinitely many points, meaning, a line, even though you might not see a lot of dots on it, it's technically made up of tons and tons of points. So the way you might see a line in the book would be a line with the arrows on it, the ends. And those arrows, again, are representing that it's going forever and ever in both directions. You may see some points on the line. There could be lots of points on the line. I'm just choosing to put two of them. You also may sometimes see like a lowercase, often a cursive type letter. I'm going to put like a cursive L beside the line. And again, we can name a line in various ways. You can name a line either by 2 points on the line, or you can name it by the single lowercase letter. Okay, so as an example here, if I want to name it by 2 points on the line, I could name it AB. And again, I can put that line on top. Make sure those arrows are on the end. If you don't have the arrows on the end, then that means you're only talking about the part of the line from A to B. But if you want to be talking about the whole line, then again, you need those arrows on the end. I could also call it line L, because again, that lowercase letter kind of to the side of the line, I could call it by that. And if you think about what's another way I can name it besides the two I mentioned, is you could just switch the order of the letters, BA, and that would be fine as well. Do not do like LB or LA, that would not work. If there were lots of points on the line, A, B, C, D, E, F, you could pick any two of those points to name the line. Okay, now if you think about a plane, look around your room and see if you can find an example of a plane. Some things that people mentioned in class the other day were like the ceiling, the floor, the walls, the desk, the board, lots of different options there. I'll just put the wall. You can put any of those examples. Again, the description of a plane is it's represented by a flat surface that extends in all directions. In terms of that, I think with the line, people can see that those arrows means it goes forever in both directions. For a plane, you're often going to see in the book that it's a four-sided figure. Often looks kind of like a parallelogram. But the plane technically goes forever in all four directions. So don't forget about that. And it contains infinitely many lines. So tons and tons of lines, even though they might not all be drawn, you might not actually see them. And since lines are made up of lots and lots of points, then technically a plane is made up of lots and lots of points. And again, it has no thickness. Same idea as the point in the line. So if you look in the book, you may see some points on the plane. Like I might have point A, point B, point C. But I also may see like a capital letter in the corner of the plane. I'm going to call it plane P. So again, different ways to name a plane. That's a lot of what this chapter is kind of getting used to a lot of words and definitions, and also just how to name things correctly. So I can either name this plane by the capital letter that's in the corner that does not actually have a point by it, or I can name it by 3 points, any 3 points in the plane. But there's one condition to that. They cannot lie on the same line. All 3 points cannot lie on the same line. 3 points in the plane that don't lie on the same line. Okay, so some examples of that would be, I could name this plane plane P. Let's switch colors here. So I could call this plane P, or I could call it plane ABC. Okay, in any order of those 3 letters works. If someone else wanted to go BAC, that would be fine. So any 3 points in that plane, as long as they don't lie on the same line. So I want to show you kind of a non-example here. Sometimes it's good to visualize that as well. So say I had a line within the plane and it had a D, E, and F on it. And say I had another point over here, I'm going to call that one G. So what I would like you to do now is think of, based on the definition I gave of a plane, what would be 3 letters that would not be a way to name this plane. So if you think about that and write that down, that option would be DEF, would not work as an example. Okay, because like we said here, those 3 points lie on the same line. So we're really just talking about that line, not that We haven't added in that extra dimension to make it the whole plane. So this is one that does not work. I'll cross it out there so we show that it doesn't work. But one that would be fine would be like DEG. That would be good, or EFG. In this particular picture, we have to include that G. Okay. All right, so let's keep moving here. Okay, so now a couple definitions. It says points that lie on the same line are, this is a word you may not have heard before, and it is called collinear. Points. Okay, and again, if you kind of think about what word you see within the word collinear, you can see the word line, or some people see the word linear. So if you kind of forget what that means, then again, you kind of see that clue in there that those are points that lie on the same line. So think about what points in the same plane would be called. Similar to collinear would be coplanar points. And again, that's probably a word you haven't heard before, but kind of makes sense based on the name. All right, on this next part, I know some of you got to do this next part in class, and some of you did not. So I would like you to, if you didn't get a chance to already do it in class, I would like you to think about what the answers are before you listen to what I say that the answers are. I think it's a good thing based on what we've talked about so far. So you're going to answer one word in each box for the intersections. If you think about what an intersection is, it's where the two things touch each other. We're talking about two lines, a line and a plane, and then two planes. And where they intersect is going to be either at a point, at a line, or at a plane. Okay, so in each of these three boxes, you're going to write either point, line, or plane, just one word in each. All three words may not end up getting used. Maybe something gets used more than once. Maybe it's the same answer for all. I want you to think through that. When you're thinking through this, I suggest either picking up objects that you can hold, like two pencils or two pens to represent two lines, picking up a line, a pencil, and like a plane, a piece of paper or index card. And then for two planes, pick up two index cards or two sheets of paper and kind of move those and kind of see where you find them intersecting or touching each other. Or you can draw pictures. Some people I noticed in class the other day were drawing pictures to represent what was going on here, and then that helps them see where they intersect. So go ahead and pause the video. Go ahead and try that. Put something down. If it's wrong, no big deal, and you can fix it in just a minute. Okay, so hopefully you tried that, and go ahead and check your answers now. Two lines are going to intersect, and I can even draw a little picture to help you see it. That's helpful, but two lines are going to intersect just at one spot, which would therefore be a point. Okay, a line and a plane. That gets a little 3D, but if you think about a piece of paper and then you take a pencil and punch a hole in that sheet of paper, if you think about where does that pencil and that sheet of paper touch each other, they just touch each other at one spot, which is therefore a point. And then two planes. Again, if you hold two index cards and kind of act like, one is kind of colliding in with the other, you can see that they are touching each other at a lot of points that are all in a straight line. So they would intersect at a line. All right, let's keep moving. So on this next section, for example 1, the things we have talked about, you should be able to answer all of these questions. So again, the more you practice it, the better you're going to get at this. So I would recommend pausing the video once again, trying to answer these questions that are here. For example 1, A, B, C, D, and E. And then you can turn the video back on and check your answers and fix them as needed. One thing to keep in mind is that there's often more than one right answer in geometry. And so if I say answers may vary, I may not write every single option down as the answer, so it might not have the answer down that you have. But if I say answers may vary, then that means that kind of look at what I put and compare it to what you put, and yours certainly may be right. If you're not sure, star it or circle it, and that would be something you could message me about or ask me about in class. So go ahead and pause the video, go and try example 1, A, B, C, D, and E, and then join back in and see how you did. Okay, so hopefully you tried these on your own already. If it says list 2 other ways to name line QT, you can see this line. Remember we said that you can name a line by the lowercase letter kind of off to the side, and that's an L. So you could name it line L. Okay, or we said you can name it by any 2 points on that line. And if you see, there are 4 points on that line, R, Q, M, and S, and you can name any 2 of those to name that line. So if I just say RQ, that would work. And I'm putting my little line symbol on top. But any of the other options are fine too. QM, MS, QS, RS. Again, lots of different options there. Okay. On the next one, so again, answers may vary on A, but those are just 2 examples that you could have that I wrote down. On B, it says list 2 other ways to name plane P. So you can see that P is in the corner. It doesn't actually have a dot by it, so you could just call it plane P, or you can name it by any 3 points in the plane, but they may not all 3 lie on the same line. Okay. So in this particular case, I put RVQ, okay, and I also put QSV. Okay, you basically have, if you're naming 3 letters, you have to include the V. Okay, and then the other 2 letters can be R, Q, M, or S, any 2 of those. Do not include the L and do not include the P when you're naming the 3 points. Okay, but again, answers may vary on that. There are plenty of other options, but V does have to be one of the letters. Okay, and do not use P or L. All right, on C, it says name 3 collinear points. Okay, so again, that's just asking for 3 points that are on the same line. And if I'm naming points, I want to make sure I put commas in between. So in this case, I can say R, Q, M would be fine. Or, someone else might say QMS, that would be fine. But again, you're just naming 3 points that are on the same line. Okay, on D, it says, what are the names of 4 coplanar points? So that's just asking you to name 4 points that are on the same plane. Again, there are basically 5 points on the same plane, V, R, Q, M, and S, and you can name any 4 of those. So I have V, R, Q, and M. But again, any 4 of those would be fine. And then on E, it says, what are 2 points that are not coplanar with R, S, and V? So if you find R, S, and V, that's the plane, kind of in that parallelogram. And they're asking what are 2 points that are not in that plane. Well, if you think about it, this picture is like a sheet of paper with a pencil stuck through it. And like point T would be up at the eraser of the pencil, and point N would be down at the tip of the pencil. Okay, so if you think about a pencil punching through a sheet of paper, T and N are not on the same plane or sheet of paper. So those would be the answers to E. So, A, B, C, D, and E, you could have different answers than what I have. But on E, those are the only correct answers on E. You wouldn't want to say M because that's not a point. Okay. All right, moving right along. Next part is talking about a line segment. And for this line segment, it says a part of a line that consists of 2 endpoints and all the points between them. Unlike a line, it can be measured because it has endpoints. Uh-oh. I think my hand did that. There we go. So an example of that would be, I can call this A, I can call this B, but I don't have arrows on the end. So I could name this as AB, or I could name it as BA. It doesn't matter the order of the letters. For a ray, it's a part of a line that consists of one endpoint and all the points on the line on one side of the endpoint. Rays are named by stating the endpoint first and then any other point on the ray. The order of the points indicates the ray's direction. So big thing here that sometimes people forget is that if I'm going to name this ray, the endpoint has to come first. Okay, so I have to call, if I want to name kind of this whole arrow ray that I see, I've got to start with the E, and then I can name any other point on that ray next. So I could use the F or the G next, and then your arrow's always going to go to the right when you name a ray, even if it's facing the other direction. So this one I could call EF or EG. Either one is fine, but both of those mean the same thing. Okay, so you name the endpoint first, then name another point on the ray, and the arrow always goes to the right. Okay, opposite rays are two rays that share the same endpoint and form a line. So in this case, if I want to name a pair of opposite rays, I have one that starts here and goes forever this way, and I could call that one PR. And then I have one that starts here and goes forever that way. And for that one, I want to name P first because that's the endpoint of that ray. And then I'm going to name the Q, but my arrow is still going to go to the right, even though, that part of the ray is going to the left. Okay, so PR and PQ both start at the same endpoint and they shoot off in opposite directions. Okay, and then the last little bit is if you look at that same picture we were just working with, you can answer a few questions about what you see in that picture. So again, I would pause the video, go ahead and try and answer those three, and then you can jump back on and compare them to my answers. Okay, so hopefully you just tried those. Using line QR above, what are the names of the segments? So the segments that you can see in this picture are QP, PR, and sometimes people forget about QR. So don't forget about that one. That is its own segment. Again, they asked for segments, so I didn't put arrows on the end. It says, what are the names of the rays in the figure? So there are technically multiple rays in the figure. Okay, I've got PQ starting at the P and going to the left. I've got RQ starting at the R and going towards the left. But I could also call that RP. So I'm going to put an or here because these two mean the same thing. I don't want to treat them as two different things. They look different, but they're technically the same. Another one is QP, starting at the Q and going forever to the right, or QR. Again, those two mean the same thing. So I'm not going to treat them as two different rays. And then the last one would be PR, starting at the P and going forever to the right. Okay, and then the last one, which of the rays in part B are opposite rays? We really already answered that question up above, and that was PR and PQ. Okay, so hopefully that makes sense. Again, feel free to star or circle anything if it's something you'd like to go back over in class or that you have questions on. And I will post the section 1 of 3 video as its own video in just a moment.